Let's do a hypothesis test where we test a claim about a proportion value where that proportion P represents proportion of male BSN students. Okay, all right. To do a hypothesis test, we're going to follow several steps. I'm going to break it down into basically 6 steps, where the first step is to write our null and alternative hypotheses. So to help us write the null and alternative hypothesis, let's take a look at the original claim. And I always like to highlight the original claim and then rewrite it in symbolic form. So we're testing the claim that the proportion of male BSN students is less than 15%. So using symbols to write this original claim, we would write this as P is less than 0.15. So if your proportion is given to you as a percent, always convert it to its decimal equivalency when you're doing a hypothesis test. Now, notice that this original claim here does not contain the equal sign, so that immediately becomes our alternative hypothesis. So I will write it down here, P less than 0.15, and then keep track of the original claim. So notice that the original claim is in the alternative hypothesis. And then the null hypothesis always contains the equal sign. So I would write P equals 1.5 for the null hypothesis. Now, notice that the alternative hypothesis contains that less than sign. This means that we have a left tail test. So I'm going to draw myself a bell-shaped curve on the right. And then let me erase this so I have some more space here because I know I'm going to run out of space. So I'm going to draw myself a bell-shaped, oh, let me try that again. Draw myself this bell-shaped curve on the right. And then I'm going to label my null hypothesis value at the center. And because I have a left tail test, I'm going to go ahead and define my left tail and shade in my significance level. So the area that I'm shading in red here, this has an area of 0.05, and this also defines the critical region. Okay. All right, the next step in doing a hypothesis test is to take a look at our sample data and calculate our test statistic. Okay. So our test statistic when we're testing a claim about a proportion is always going to be a z-score. So I need some z-score here. And to get that z-score, I need some sample data. And the sample data that I'm going to look at is the sample proportion. So I need a p-hat value. Now, remember p-hat is x over n, where x represents the number of male students. So in this particular problem here, I'll highlight that in green. We have 350 BSN students. That's our sample, and 42 of them are male. So this gives me a p-hat value of 42 over 350, or 0.12, which is 12%. Now, I know you're probably looking at your sample data and going, well, wait a minute, 12%, that is less than 15%. So isn't that enough information to prove that the proportion of male students is less than 15%? And the answer is no, this isn't good enough, because we want to make sure that the difference that we see, so 12% is different from 15%. We need to make sure that this difference is a real difference, meaning that it is a statistically significant difference. And the reason for that is because every time you take a sample from the population and look at your sample statistic, any differences that you see, it could just be due to chance, okay? Not because the difference is real. So the only way that we'll know if this is statistically significant or not is we have to calculate the p-value of getting a p-hat value of 0.12. So that's the next step. The next step is to calculate the critical value, and then also calculate a p-value. And then I'm going to show you how to use the critical value method and the p-value method to make a decision about the null hypothesis. And then later on, you'll learn how to use confidence intervals as a method to test a claim. But here, I'm just going to focus on critical value method and the p-value method. So to use the critical value method, we need to calculate our critical value, which is a z sub alpha. So because this is a left tail, I'm looking for a critical value of z sub 0.05. But actually, before we do the critical value, I just realized that I haven't actually calculated my test statistic yet. So we haven't gotten that z-score yet. So let me go back to step 2 and finish step 2. I just got too excited here and got ahead of myself. So if you're using formulas, the formula to calculate that test statistic is p-hat minus p divided by the square root of p times q over n. Okay, all right, so here our p-hat value is 0.12, p is 0.15, Square root of p is 0.15, and q is just the complement of p, so the complement just means what is 1 minus 0.15, and then let's divide it by our sample size of 350. So because this is a z-score, I'm going to take it out to 2 decimal places, so that gives me negative 1.57. I'm going to highlight our z-score here in green, so that's negative 1.57. And I'm going to mark it on the bell-shaped curve here. So that's our z-score, our test statistic, negative 1.57. And again, that's the test statistic that corresponds with our sample proportion of 0.112. Okay, now the next thing that we're going to do is go back to step 3 and calculate that critical value. So the critical value is the z-score. So I'm going to write it here. The critical value is the z-score that separates that red shaded region on the left from the rest of the distribution. So you can actually use your calculator for this because you learned how to do this in a previous lesson. Use the inverse norm function on your calculator, and because we have a left tail test here, you can go ahead and put in the area to the left as 0.05, and then type in 0 and 1 for mu and sigma, and this gives us a critical value of negative 1.64. So this marking right here that marks that black line that separates that red shaded region is negative 1.64. Okay, now that I have my critical value, I'm going to go ahead and calculate my p-value for my test statistic from step 2. So in step 2, we found out that our test statistic is a value of negative 1.57. So the p-value is just the probability of getting a test statistic of negative 0.57 or something less than that, so more extreme than that. So I'm going to shade in the p-value in the graph. So the area that I just shaded in green represents the p-value. So a p-value is a probability, and you can also use your calculator for this. So to get this p-value, you can use normal CDF on your calculator and type in negative 1e99 because that's the left bound. The upper bound is so that's our lower bound. Our upper bound is negative 1.57. Again, I'm trying to find the area of the green shaded region. And then put in 0 and 1 for mu and sigma. When you press enter, your calculator should give you a p-value of 0.0582, which is approximately, so I'm going to write down here, our p-value is approximately 0.06 if I round, okay? All right, so now let's make a decision. So make a decision about the null hypothesis. Okay, so the null hypothesis is that p is equal to 0.15. So I'm going to show you 2 methods. Let's first start with the critical value method, which I'm going to block here in red. So if I use the critical value method says if my test statistic falls in the critical region, then I would reject the null hypothesis. But in this example here, notice that our test statistic, which is negative 1.57, it does not fall in the critical region. So if you're using the critical value method, we would fail to reject the null hypothesis. So I'll write here that since the test statistic, and remember that test statistic is that negative 1.57, okay, does not fall in the critical region, we're going to fail to reject the null hypothesis, okay? Now let's take a look at the p-value method. So the p-value method should lead us to the same conclusion as the critical value method. So the p-value method involves us comparing the p-value to our significance level. So notice here that the p-value is the green shaded region. It's much larger than our significance level, which is the red shaded region. So if our p-value is greater than our significance level, we always fail to reject the null hypothesis. So here I would write down that if I'm using the p-value method, since the p-value, which is just slightly larger than our significance value, but it is larger, okay, is greater than our significance level of 0.05, all right, we also fail to reject the null hypothesis. Okay, and so now we need to actually state our final conclusion. I'm kind of running out of space here, so I'm going to do it up at the top on the side here. We need to actually write our conclusion that addresses the null hypothesis, or that addresses the original claim. So basically, what does it mean for us to say that we fail to reject the null hypothesis? I'm going to use purple here so you can follow along with me. Up in our hypothesis, in our first step, okay, the original claim is the alternative hypothesis, but the conclusion that we just made was that we fail to reject, right, the claim that P is 0.15. So basically what we're saying here is we're saying that we don't have enough evidence, right, to reject that the proportion of male students uh, is something other than 15%. In this case, we're trying to see if it's less than 15%, but we don't have enough evidence to support that. So because we don't have enough evidence to support our original claim, we can't just ignore the fact that P could be 15% or 0.15. So our final conclusion, we would state it like this. We would say there is not sufficient evidence to support, and we're supporting the original claim, which is that to support the claim that less than 15% of BSN students are male. Okay, and that's how you would do this type of hypothesis test.